For centuries, it has stood defiant, a silent sentinel against the ravages of time, a riddle wrapped in iron, immune to the decay that claims all else. This is the story of the Iron Pillar of Delhi. Crafted over 1,600 years ago, it towers above the Qutub Minar complex, a testament to the ingenuity of ancient India. But what makes this seemingly ordinary pillar so extraordinary? Rust, or rather the complete lack of it. While iron crumbles to dust almost everywhere else, this monolith has remained stubbornly pristine, baffling scientists and historians alike. What secrets does its metal hold? The pillar itself is a sight to behold. Over 7 meters tall, its smooth, dark surface gleams under the Indian sun, a stark contrast to the weathered stone structures that surround it. Its weight is estimated at over 6 tons, a colossal feat of engineering for its time. Look closely, you'll see inscriptions etched into the iron, writings in Sanskrit that tell a story, a dedication to a powerful king named Chandra, believed to be Chandragupta's sect of the Gupta dynasty, who ruled in the 4th. The inscriptions are not just decorative, they provide vital clues about the pillar's origin and purpose. They speak of a Vaishnav temple, a place of worship dedicated to the Hindu god Vishnu, where the pillar was originally erected. It was likely a standard, a victory column, commemorating Chandra's conquests and achievements. Later, it was moved to its current location, in Delhi, becoming a silent observer of the city's ever-changing history. But it's not the inscriptions or its age that truly captivates. It's the unwavering resistance to rust. The pillar is composed of 99.72% iron, a seemingly simple composition, yet it defies all expectations. In a climate as humid and corrosive as Delhi's ordinary iron would have disintegrated long ago. To understand this anomaly, we need to delve into the metallurgical processes of the Gupta era. They weren't simply melting iron ore and casting it into shape. They were employing sophisticated techniques involving repeated heating, hammering, and quenching. This process, known as forging, not only shaped the metal but also refined it, removing impurities that contribute to corrosion. One key aspect of the pillar's rust resistance lies in its unique microstructure. Microscopic analysis reveals a high concentration of phosphorus, approximately 0.15%, an element not typically found in modern iron or steel. This phosphorus, sourced from the raw materials used in its creation, played a crucial role in forming a protective passive layer on the pillar's surface. When exposed to the environment, the iron reacted with the phosphorus to create a thin, tightly adherent film of hydrogen, phosphate hydrate of iron. This film acts as a barrier, preventing further oxidation and shielding the underlying metal from the corrosive effects of oxygen and moisture. It's like an invisible suit of armor, constantly renewing itself and protecting the pillar from harm. Furthermore, the forging process itself contributed to the pillar's longevity. The repeated hammering and heating created a dense, homogeneous structure, minimizing the presence of pores and cracks where corrosion could initiate. The blacksmiths of the Gupta period, although lacking modern scientific understanding, possessed an intuitive knowledge of metallurgy passed down through generations of skilled artisans. They understood the importance of purity, the role of additives, and the transformative power of heat and hammering. Their craftsmanship was not just about creating an object, it was about creating something that would endure. Consider the scale of the undertaking. Smelting 6 tons of iron required vast quantities of charcoal, meticulous control of temperature, and the coordinated effort of numerous skilled laborers. The process would have taken weeks, if not months, demanding unwavering dedication and expertise. The pillar wasn't cast in a single mold. Instead, it was likely forged from individual iron blooms, small masses of spongy iron produced in bloomery furnaces. These blooms were then repeatedly heated and hammered together, a process known as welding, to create larger sections of the pillar. These sections were then joined together, creating the seamless, monolithic structure we see today. This intricate process highlights the remarkable skills of the ancient Indian blacksmiths, their ability to manipulate and control the properties of iron with incredible precision. And finally, let's not forget the environment where the pillar stands. While Delhi is known for its humidity, the pillar's elevated position and the relatively dry soil around its base contribute to its preservation. The continuous flow of air helps to evaporate moisture, reducing the time the iron surface is exposed to corrosive elements. Furthermore, the lack of any protective coating like paint or varnish is also significant. Modern coatings can sometimes trap moisture, accelerating corrosion beneath the surface. The pillar, in its raw, unadorned state, allows the passive layer to form and regenerate naturally, ensuring its continued resistance to rust. The Iron Pillar of Delhi is therefore not just a monument to a king, but a lasting testament to the ingenuity, skill, and profound understanding of materials possessed by the ancient metallurgists of India. It is a tangible piece of history that continues to inspire awe and wonder, challenge to modern science, and a symbol of enduring human achievement. While the presence of phosphorus and the formation of a passive protective layer is the generally accepted explanation for the iron pillar's rust resistance, it's not the complete story. Scientists continue to debate the precise mechanisms at play, and alternative hypotheses have been proposed to account for its remarkable longevity. One intriguing theory suggests that the composition of the iron itself might be even more complex than initially thought. While analyses have consistently shown a high degree of purity with over 99% iron, some researchers believe that trace amounts of other elements present in parts per million could be playing a significant role in inhibiting corrosion. These trace elements, not easily detected with conventional analytical techniques, might be influencing the formation and stability of the passive layer, enhancing its protective properties. The source of the iron ore used to create the pillar is another area of ongoing investigation. It's believed that the ore came from mines in central India, a region known for its rich deposits of iron ore. However, the specific mine or mines used remain unknown. Understanding the geological composition of the ore is crucial, as it could shed light on the presence of trace elements and their influence on corrosion resistance. Furthermore, the exact smelting and forging techniques employed by the Gupta blacksmiths are still subject to speculation. While we know that they used bloomery furnaces and employed repeated hammering and heating, the specific parameters of these processes, the temperature, the duration of heating, the type of fuel used are all unknown. Replicating these ancient techniques in a modern laboratory setting is challenging, but it's essential for understanding how the blacksmiths were able to achieve such remarkable results. Another debated point is the role of atmospheric conditions over the centuries. While Delhi is generally humid, the microclimate around the pillar might have been different in the past. Changes in rainfall patterns, wind direction, and pollution levels could have influenced the rate of corrosion and the formation of the passive layer. Some researchers argue that the relatively low levels of pollution in ancient Delhi compared to modern times could have contributed to the pillar's preservation. The absence of industrial pollutants such as sulfur dioxide and nitrogen oxides would have reduced the acidity of the atmosphere, slowing down the corrosion process. Conversely, other scientists suggest that the pillar's initial exposure to the elements may have been crucial in establishing the protective layer. They propose that a period of controlled oxidation in a specific atmospheric environment could have been necessary to form a stable and durable passive film. This initial conditioning process might have been crucial in preventing subsequent corrosion in the more corrosive environment of Delhi. The orientation of the pillar itself might also play a role. The pillar is aligned in a specific direction, and it's possible that this orientation affects the way it interacts with sunlight and wind, influencing the temperature and moisture levels on its surface. Some researchers have proposed that the pillar's orientation minimizes exposure to direct sunlight, reducing the temperature fluctuations that can contribute to corrosion. The impact of bird droppings on the pillar's surface is another factor that has been considered. Bird droppings are acidic and can potentially corrode iron. However, the pillar's smooth surface and the relatively dry climate around its base may help to minimize the impact of bird droppings. The rain washes away much of the residue before it can significantly damage the passive layer. The effectiveness of the passive layer is also a subject of ongoing research. While it's generally agreed that the passive layer protects the pillar from corrosion, its exact composition and structure are still not fully understood. Some researchers believe that the passive layer is not a uniform film, but rather a complex mosaic of different iron oxides and phosphates. The relative abundance and distribution of these different compounds may influence the layer's protective properties. Furthermore, the long-term stability of the passive layer is still a matter of debate. While the pillar has remained relatively rust-free for over 1,600 years, it's possible that the passive layer is slowly degrading. Over time, future research will be needed to assess the long-term durability of the layer and to predict the pillar's future corrosion resistance. Finally, some historians even suggest a spiritual explanation attributing the pillar's rust resistance to divine intervention or the power of ancient rituals. While this explanation is not scientifically verifiable, it reflects the deep sense of awe and wonder that the pillar inspires, a sense that transcends scientific understanding. The Iron Pillar of Delhi remains a scientific puzzle, a challenge to our understanding of metallurgy and corrosion. It is a reminder that even in the age of advanced technology, there are still secrets to be uncovered and lessons to be learned from the past. The Iron Pillar of Delhi is more than just a historical artifact. It's a living laboratory, a testament to the remarkable skills of ancient Indian metallurgists. Its enduring resistance to rust continues to fascinate scientists, historians, and engineers alike. It stands as a powerful reminder that ancient technologies, born from careful observation and accumulated knowledge, can surpass our modern understanding. While the exact secrets of its construction are still debated, the pillar's very existence compels us to rethink our assumptions about the capabilities of past civilizations. It showcases their deep understanding of material science, their ingenuity in overcoming technological challenges, and their commitment to creating structures that would withstand the test of time. The pillar encourages us to reevaluate our current approaches to material science and engineering, to explore the potential of ancient techniques and to learn from the wisdom of the past. The Iron Pillar of Delhi serves as a beacon, inspiring future generations of scientists and engineers to push the boundaries of knowledge and to strive for innovation. It's a symbol of human ingenuity, a reminder that with dedication, creativity, and a deep understanding of the world around us, we can achieve seemingly impossible feats. It's a call to respect the wisdom of the past while embracing the possibilities of the future. Please like and subscribe, and I'll see you in the next video. Thank you.